Hello and good afternoon, everyone. This is our knowledge series of the project India EU ICT Standardization. Today we have our 16th webinar, and the topic of the webinar is towards converged wireless networks, interplay of broadcast and cellular network technologies. And I don't want to steal the show from Arindam or Mr. Mittal, but I think as a ordinary mobile phone user today, everybody is having a lot of video data, and I think Arindam is going to throw some light at how the choking mobile networks can be freed up using broadcast technology with cellular technology, and that can make more faster video connection for cellular networks. But to further introduce our speakers for the day, as usual, since it's a 5G topic, so we have our advisor for the 5G topic, Mr. Mittal, who is advisor to the Indian Telecom Standards Development Body called as CSDSI. And Mr. Mittal, as you know, is the seasoned expert in the topic of 5G especially, and he has been, let's say, in the field of telecommunications for the last 40 years, especially involved in the R&D and from the government side, in the Department of Telecom, working on variety of domains like satellite communication, OFC, mobile network, switching system, transmission system, network management, licensing, regulation, testing. He has also headed the Telecom Engineering Center, the technical arm of Department of Telecommunications, and he has represented Government of India in various bilateral and multilateral international meetings. And I think especially in current times, Mr. Mittal is very active in 3GPP platform, if I'm not wrong, and he's our go-to person when it comes to anything related to 5G. So welcome, Mr. Mittal, for
Thank you,
our
Mr. Sachin.
important topic today. And I think some of you must have already heard of name of the company Sankhya Labs, as it has been making some waves already in the Indian media about launch of their new chip. And I think Arindam is going to talk more about it. But we have a great pleasure of having Arindam Chakrabarti today, who is principal architect of Sankhya Labs. So Arindam has done his graduation in electronics and communication engineering from uh, Delhi College of Engineering, post which he did his post graduation from IIT Delhi, and he has worked for CDOT, which, as you know, is a premier research center of Government of India, and he has worked there in the field of optical communication. And after that, he has spent some time with Reliance Communication, Rancore Technology, and various other uh, say multinational companies. And now with Sankhya Labs, he's working on the topic as we talked about today. So without further ado, Arindam, I think you are doing very exciting work. So we look forward to hear from you. We have people joining all over the world, so you may educate further us on the topic. So over to you, Mr. Mittal. Before Arindam opens the topic, if you want to set the context for today.
Thank you, Mr. Sachin. And good afternoon from India to all the people who are on this webinar, and welcome. So, quickly introducing the topic. As you see from the topic, it is about broadcast and cellular. We also call it broadband broadcast convergence in short. All of us are aware, and as a user also we see that we have started consuming a lot of video content on social media and even otherwise on our mobiles, and it is gradually increasing, and the forecast is that it is doubling, almost doubling every year. So, in spite of mobile technologies giving huge bandwidths and 5G will multiply it by 100 times, but the kind of video content download and services which will be hosted on these platforms, there will be always a pressure on the mobile network bandwidths which can be assigned to only video. So this idea of convergence of broadcast and mobile has come from that position, that how to offload the video part from partially or to the extent which is possible on some other networks. And those networks could be broadcast networks in the UHF frequency range. And especially in India, UHF frequencies are not fully utilized for digital terrestrial transmissions. And so there is an opportunity for broadcasters to come together with the telecom operators to join hands, where the convergence of UHF broadcasts and mobile can take place, which utilize each other's strengths. And the direct to mobile transmissions happen for broadcast and video. Whenever the telecom network is overloaded, it can offload to that, and parallelly the broadcasters can continue with their broadcast services directly to the mobile. So, and there are very good technological innovations which are possible. And Sankhya Labs has developed a chip for doing all this, to enable this or to make this happen. So I will not take more time, and the content of what Mr. Arindam is going to talk. Over to Mr. Arindam to enlighten all of us about this topic. Thank you very much.
Okay, thank you, Mr. Mittal. So as mentioned by Mr. Mittal, that there has been a rise of video delivery both in OTT forms and also live traffic over the mobile networks, and it has grown tremendously over the years. And in fact, the amount of spectrum the various operators have been able to acquire over the years does not match the kind of traffic growth that has taken place. So as a result, that we get a very poor patchy mobile services. And to make it worse, since the same pipe is also used for other services like voice and others, we are seeing a definitely a deterioration in the quality of service of all across the spectrum, and which is chiefly recognizable in the case of voice. So you get more call breaks, you get poor, you get disrupted audio and all these problems. That is because that is a manifestation of the kind of congestion we have in the network. In video, even though the quality is good, we see occasional buffering, and this is a problem that will go worse as the time progresses. Now, if we see that what are the spectrums that we have got to give cellular services. So historically, if you see, earlier we had we started with 2G services, where almost the whole spectrum was almost sub 1 gigahertz. So at low frequencies, we had very good reach. We could reach a huge amount of area. Now with time, what happened is, as the number of customers grew, more and wider bandwidths were required. So all the 3G and 4G services came to be used between this 1 gigahertz and 2.5 gigahertz bands. So that is where we have got more bandwidth to give better services, but we need the reach reduced significantly. So we need to have smaller and smaller cells and more number of cells towers to serve the same amount of people with greater bandwidth. With 4G, if you look at this at 2.3 and gigahertz band, where most of the spectrum is available, the reach is very poor, wall penetration, indoor coverage is poor. Now if we think that all these problems are going to be solved in 5G, then we should rethink about it, because as we move from 2G, 3G, 4G and to 5G, the basic laws of radio physics does not change. So for 5G, as most of the equipment vendors will tell you, that it is best to have at least a 50 megahertz chunk of spectrum per operator. Now to get this kind of big frequency chunks, we have to move to higher frequencies, especially the 3.5 gigahertz band and to the millimeter wave bands. Now at those frequencies, the coverage will be very poor. We can think of it as a whole network of small cells. So using such infrastructure, it will be good to say, for example, for indoor coverage or something of you can think of it as a more of a evolution of Wi-Fi rather than evolution of 4G. So of course there will be cases where you can, I mean, you can have handoffs, you can many things, almost like it will be basically making the Wi-Fi network more like 4G network rather than being a big evolution of the 4G network. Now one of the things that we see that that there is a huge chunk of spectrum that is lying in the UHF band, which are being traditionally allocated to digital television transmission. Now, the thing is that in India and in many other countries, the broadcasters have not been able to monetize the bands properly, and there is a huge unused capacity in that band. So in some of the countries, what is happening is that more and more of this band are getting clipped away, especially on the higher frequency side like 600 megahertz or 700 megahertz, and they are being used for giving cellular services. But again, the amount of spectrum in those bands are not quite suitable for 5G use. So people will be using most of them in 3G or 4G services, yeah, at these frequencies. So in India, because since his whole spectrum is owned by the government and is being used by Doordarshan, the amount of deployment of it is very patchy, and the coverage, if you look at pan India in these bands, is not that good. Also, not more than 2 or 3 transmitters exist in a given area. So almost one can say that about 110 to 150 megahertz of spectrum is lying back underutilized in the current scenario in our country. Now, so that is the thing that in this presentation we are going to point out, that how this band can be used for proper use. Now, traditionally, what has happened is that the broadcasters have not been able to very efficiently use the spectrum. So one of the biggest reason is, for example, is that since the transmitters have very high EIRP, almost like few 50 to 100 kilowatt kind of EIRP is there. So what happens is that if I am transmitting at, say, if you look at the diagram at the frequency F1, 2 adjacent bands need to be kept empty so that I can transmit at another frequency F2 in the same geographical location. Otherwise, what will happen is that, for example, if I have 2 towers, say, separated by a distance of, say, 10 or 5 or 10 kilometers, then if I am right near the tower which is transmitting at F2 and I try to receive F1, that frequency of F1, then due to the leakage from the F2, which will be stronger than the signal received from F1, so I won't be able to receive anything. So that is why when we have more and more transmitters in the same location, and because of the high EIRP, we have to leave a lot of vacant spectrum. And so basically, to give a given frequency, given bandwidth and a given area, 3 times more bandwidth is required just to take care of these problems. So this is one of the biggest reasons why this band has not been used efficiently. So one of the things that we have been proposing is, along with the use of these frequencies, is that to come up with a new architecture which is cellularized. That means that we have got broadcast towers and broadcast infrastructure and on each mobile tower. So it is basically overlaying a basic mobile network with a broadcast network. So one of the basic thing is that what we are proposing is that it is not a replacement for cellular technologies. It is using the UHF band frequencies to augment the cellular transmissions, so that whatever can be broadcasted be broadcasted. So for example, if there is a live match like IPL or say Olympics then what will happen is that instead of having, say, suppose I have got within a cell, I have got hundreds of users consuming the same content. Instead of having hundreds of unicast connections, I have got one broadcast connection which will connect to all the users. So that is the basic advantage of broadcast technologies. Now thing is that nowadays people are also trying to are more intended to use things like the video on demand. So even in those cases, if we see that a kind of a content is there which is predicted to be of being viewed by multiple users, it can be sent not as a live stream but as a file to the mobile phones and cached there so that people can view it. So already if you see, the most of the DTH players are having these facilities where you can download over the satellite link movies and content which is stored in the set-top boxes, and they can see later on. So another thing that this architecture ensures is that it ensures much better coverage compared to the tall towers. So if you look at it in the broadcast network, one of the important thing in the broadcast network is that if for a given area, whatever is the most poorest signal conditions, that has to be the basic denominator by which the whole spectrum is to be used. For example, if somebody, so suppose I have a tall tower, I am transmitting several kilowatts of power, but I am covering an area of, say, for example, with a 60 kilometers or 100 kilometers of radius. So the edge, depending on what the signal is perceived at the edge of the network, that will determine what is the modulation or coding to be used, and that will determine my spectral efficiency. Now, using a cellularized architecture, I have got several of low power transmitters, almost covering several, if corresponding to one or say 3 or 4 what you call cellular base stations, and from there I'm transmitting, say, something like 50 watts or 20 watts of power, I will get a much better coverage and more uniform coverage over the whole area. So one of the important concept here is that of SFN. So what happens is that the same content in a time synchronized manner is transmitted from each and every transmitter of the transmitters. So if I have an area which is an overlap of multiple transmissions, they won't cause interference, but they will reinforce each other. So the minimum signal quality improves significantly. If you see in this diagram, say in a cell, I have got a central region of good coverage, and along the periphery it will be poor coverage. Poor coverage means not just the signal is strong, signal maybe is weak, but it may be strong also, but the interference from neighboring cells may be also high. That is the biggest problem we feel, because even in mobile phones, if you see that in many cases the call quality is poor in spite having the strong signals. That is because the phone is getting signals from multiple sources and they are interfering to each other. In SFN, what will happen is that since it is a broadcast network, the same content is transmitted from all the nodes. So it is possible. So in this case, the transmissions are also time synchronized in nature. So whatever content signal is received from one tower is reinforced by the signal from the other tower. So it causes a good signal to noise ratio even at the cell edges. So now the thing is that using this kind of architecture, one can easily reach the ultimate. One of the major goals is of any broadcaster is that we can target mobile devices. So traditionally, if it had been the high tower architecture, then the networks were designed so that people have rooftop Yagi-Uta antennas and receive the signal, it goes to the television. Now if we are also seeing that there's a tendency especially with these OTT players, is that people are consuming more and more video traffic on their mobile phones. So to reach the mobile phone, the signals has to travel one or two walls before reaching the end device, unlike the earlier case where we had one Yagi-Uta antenna on the rooftop. So for that case, one of the option is to have even more high power transmitters at one location, which is getting more and more impractical. The other option, as I mentioned earlier, is the SFN. So that is the only way forward for the broadcasters. And another major thing is that since now the power of each transmitter is not that high, it is on the same order of that of cellular transmissions, I can use adjacent channels. So this makes the spectrum utilization, so because of to have the same amount of, to transmit the same amount of data in this kind of architecture, first of all I can use a higher modulation and coding, so spectrum requirement reduces. Secondly, since I can pack more, I don't need to leave vacant spaces. So it is almost like 5 to 6 times, one fifth or 1/6 spectrum can deliver the same amount of services as compared to what is there currently. So in these two things combined gives a much optimized network, and it leaves out a lot of spectrum to be used in other applications, such as, for example, if more and more spectrum is allocated to cellular operations, then other services can also be improved, while the same existing services along with the projected new services can take advantage of the more efficient utilization of spectrum due to the two reasons as I mentioned. One is the spectrum we need not leave bands vacant, and secondly, since there is more uniform high better signal coverage is there, I can use higher modulation and coding. So the receiving of TV signals on a mobile phone is not something new. It has been tried many places before. For example, there was a DBBH standard where companies like Nokia came up with a mobile phone which supports TV reception. So there the problem was that the networks did not support what you call this SFN kind of a thing. It was still a tall transmission tower. And secondly, I mean it is then the users do not want to, I mean it is like what it was something like we have in today's phone, like if you want to go listen to music, you have to go to the FM radio application and then consume the content. So what we think is that in a video content kind of a thing, the user should not be bothered whether from where the content is coming. It can either be through the cellular network or through the broadcast network. So what we perceive is that the end user should be agnostic to where the content is coming. So and it should be the core network which will decide that I need to offload this much, this quantum of traffic to the broadcast network, and what should be there in the core network. Obviously, there are many services like voice and video calls which cannot be handled in a broadcast network. It has to be a cellular network. All TCP traffic is always will be through the cellular network. So it is only the UDP traffic, especially the ones that are carrying media like audio, video, or even large files. Those are the candidates which are very much suitable to be sent over the broadcast network. And if you see as you see, starting even from like standards like DBBH and now the ATSC 3.0, all of them are basically, they carry IP traffic. So instead of transport streams, they have moved on to the IP based containerization, which is very much similar to what is there in the cellular networks. So it allows a convergence of cellular, the standards itself have evolved to allow a convergence between them. Now coming to more detail into how this converged network will look like. So this I have shown with a legacy 4G network. So in a 4G, the core network is basically the EPC, which handles all the what you call mobile registration, then calling and handoff. So all these things are handled by the EPC. So what we wanted to do is to augment this EPC with a broadcast offload core. So here we have added a new element which we are calling the load manager. So the load manager is basically, you can think of it as kind of a proxy server or a kind of a deep packet inspector kind of a thing, where all the traffic passes through. So the load manager handles the traffic in a transparent manner and gets statistics out of that. Is that what are the content that is going right now is suitable to be sent on the broadcast network, and looking into the progresses that has gone in case of data mining and all the data science technologies, especially with artificial intelligence. So it is very prudent that all these statistics are put into some kind of an analytic platform where we where it is analyzed that what is the best way to partition the traffic between the broadcast and the cellular network. So what is assumed here is that we are not allowed to go inside the EPC, in the sense that there is no additional what you call standards change required to in the EPC to handle this kind of interface. So it is just like a P gateway goes through this load manager, and if, for example, we want to know the particular user location, then so almost all these 4G networks have, and even this 2G, 3G networks have kind of a GMLC kind of a location server where I know the user location. So I know that which user at which location is looking into what kind of content. So using data analytics on these kind of contents, we can decide that these are the candidate streams which is under demand right now, and these are and this should be used sent over the broadcast network. So we have borrowed some of the, because if you look at it, LTE also has a option of broadcast using a technology called EMBMS. Now EMBMS, one of the issues with EMBMS is that it is in-band, in the sense that the whole spectrum for 4G is split into a broadcast section and a broadband section. So since the operators are mostly heavily overutilizing their spectrum, it does not make sense for using this partitioning its spectrum into a broadcast section unless under heavy loads, like for example this IPL matches and other places. Otherwise, very less spectrum is available in the broadcast pipe, so as to allow an efficient offload. So what we are proposing is that we can use the UHF network and use that network to offload the traffic, and this load manager will offload it. So the thing is that to offload it, there's we have proposed two new nodes. One is the broadcast offload service center, where all the framing and all the layer 2 functions are done on the traffic to be sent on the broadcast radio heads, which is in the remote, which is co-located with the cell towers. And then we are proposing a broadcast offload gateway, which is these two functions are very similar to the equivalent functions in EMBMS. So from there is the broadcast gateway creates what you call multicast IP pipes that over the backhaul network to reach each of the broadcast radio heads. So this is how the network, so basically an end terminal in any network will have two modem sections. One is for the cellular network, which can be 2G, 3G or 4G, and the other will be the broadcast network. So it can receive things from both the pipes, while the core network, which includes the broadcast offshore core along with the APC, will decide which traffic, through a load manager, will decide which traffic goes into which network, and it will control through an end application on the user equipment from where the data comes. So one of the important things is that this is not it should not be confused with the handoff mechanism. In handoff, what happens that, for example, like Wi-Fi offload, it is a complete handoff from cellular to Wi-Fi. But here, the 4G pipe along with the broadcast pipe, both of them are active. Only thing is that the data rate and the data that received from the 4G pipe will drop once the offload takes place, but still the control information which will maintain the session and also report the UE location and quality of things, that will be still there, which will communicate to the broadcast offload core. So one of the biggest disadvantage of traditional broadcast is that there is no return path. So this technology, what we are proposing, enables us to have a return path, so that the network operator knows that if this is how I am transmitting, this is how the signals are getting received across geometry. So he can always optimize the network. So for example, if he discovers that there are a few locations where the quality of service is not good. So the broadcast network, in the broadcast network we can reduce the modulation and coding to make it more robust, with more robust FEC, with more overheads, so that those areas are tackled better. And since it is a hybrid technology, both broadcast and broadband, the excess traffic which is now no longer which can no longer be serviced by the broadcast network can be reverted back to the 4G network. So this is how, I mean, having two pipes and a feedback path, the broadcast network is now optimized in a much more better way. So normally what happens is that the safest way is in a broadcast network is to use a very robust modulation and coding, so that everybody can receive the signal. See, most often what will happen is that in an actual case, the quality of the signal received will be much better than what is, because the transmission has been set to a very lower limit. So in such a cases, it is very much possible to increase the modulation and coding depending on the actual dynamic situation on ground. And the dynamic situation on ground is now much better improved because of the SFN concept and the LPLD architecture. So this will have, so using this concept, the best modulation and coding for the broadcast can also be determined through the broadcast offload code, which includes the load manager and the analytical engine. Now coming to the upcoming 5G network. So one of the biggest thing is that in release 15 of CGPP, the 5G broadcast has not been touched at all, and it is being scheduled to be something to a later release. So what we are proposing is to make whatever our proposed broadcast core as an integral part of 5G. So we have got now a generalized broadcast offload gateway and a generalized broadcast offload service center, and along with the load manager. These are the parts of the core. While on the RAN side, we have got made this broadcast certificate an optional addition to the RAN, and the analytics part, because in 5G in core network there is an advantage. They have already talked of a function called NWDAF, which is basically the network data analytics function. So the analytic platform that we have been talking about can be combined with that. Now there are much more advantages of going inside the core network instead of being something outside, as we see in 4G. So here what is happening is that there are two nodes in the 5G network. There is the AMF, the access management function, and the service management function. So access management function, from there we can directly come to know where the users are, because knowing the location is a very important part of any analytic function. While the service management function, we can know what is the IP address allocated to the user, what are the sessions going on. So many of the functions of the load manager that we proposed earlier is now offloaded by getting more internal data from the AMF and the SMF functions. Now another important part is that because if you give any kind of a video service, there will be a issue of cache, for conditional access. Now traditionally, if you see set-top boxes, they use the smart cards along for giving an identity to each and every user. So in a cellular network, we have got this SIM card which has a map, which information is mapped to the HSS in the core network. So in 5G, one of the major innovations is that which is the UDM, which is the successor of the HSS, they can be used by third party using protocols like OAuth and others for validation. It is something like, if you see in many of the websites nowadays, use once Google or Facebook or LinkedIn credentials to authenticate a particular user. So those protocols are now allowed in 5G network. So, and third party applications can access the user database, the UDM, from where one can verify the users. So these things makes that, I mean, since in India also we are moving towards a new kind of a open cache standard for all kind of services, such kind of a model can be looked into, where we have got something that is unified across all access. So one of the bigger thing is 5G is that the core network is more access agnostic as compared to previous 2G, 3G or 4G network. So it can be Wi-Fi access or can be wireline access. So those things can also be handled by in a 5G core. So that is why we are proposing that moving to a 5G core even for 4G or Wi-Fi services makes a lot of sense for the network operators. And from here, for offload purpose, it makes even more sense because many of the functions, if you look at the earlier slide, that we have this what you call this load manager and other things which we are looking into the traffic that is passing through the network. Those are basically replicating many of the functions that are already happening in EPC. But since the EPC is a closed entity and we don't want to change the standards for EPC, so we kept them separate. But in 5G, since all the nodes have open interfaces like and based on HTTP, and there is a function, there's a network function also in the part of the 5G core that allows controlled access by the third-party elements like third-party application functions to access them. We can use them to access session-related and location-related information from the directly from the core network elements, as I have told earlier, and it simplifies the implementation of the load manager and makes it much more scalable. And another major advantage is that if we for the implementation of the broadcast offload components of the core, if we stick to techniques like SDN and NFV, we take advantages of actually using the same physical infrastructure, which is usually in the form of data centers, for coming up with the core. So anyway, operators have to make huge investments in the in their what you call data centers for their CDN and other functions. So in 5G, what the standardization body took is that use the same kind of infrastructure for building up the core network. And so that motivates us is to implement our broadcast offload core using the same elements. So one of the biggest advantage is that to make any application scalable, more robust, and elastic. So it can be sized up and down depending on the actual network requirement. So we can use the same hypervisors, the same virtual machines that are being used for all the rest of the 5G functions and also for the content delivery networks. So that is the so I conclude this my presentation by saying that this is something that can make a big difference in the coming networks, because if we move this highly growing, even a section of the highly growing video content from outside from the cellular network to a broadcast network using the same infrastructure, we can use the cellular frequencies much more efficiently and using them for improved voice and video call kind of services, while the broadcast network, which is designed for video traffic, can be used for the same. And secondly, one of the basic architecture is that if you look at my previous slide, the investment of a cellular operator into a broadcast network will be very minimal because it uses some of the cell sites and also the backhaul network. So if you see for the extra, because it is a broadcast, so the amount of data that goes into a pipe is very minuscule compared to what is going on in a cellular network, because one content is used by many viewers. So with very little incremental investment in the infrastructure, a cellular operator can use those broadcast frequencies for enhancing services by offloading traffic from its cellular network to a broadcast network, and so by this method freeing up more network resources for its traditional services like voice calls and video calls. While for broadcasters, the advantage is that it allows much better spectrum utilization by removing all the what you call spare bands that is needed. If you look at this diagram, spare bands are on both sides of the transmission infrastructure, so which are wasted because because we have been using very high power and high tower architecture. So going to a low tower infrastructure based on SFN, the frequency spectrum utilization is much improved because I am using the adjacent frequencies, and the broadcaster also gets kind of a feedback mechanism through the cellular network on who is viewing what, so he can optimize on his ad revenue and other things, and so he does not have to believe on some speculation on part of some agencies to know that how many people are viewing it. So he gets a direct feedback, and this is one of the biggest advantage that the OTT players has been utilizing over the years by going over broadband network. So basically it allows the broadcasters to act as OTT players and efficiently use its spectrum, while it is the cellular operators get the broadcast frequencies for offload. So it is basically kind of win-win situation if you look at technically for both of them. So this is how, at this point, this is all I had to say. So I hope that there are many questions which we can answer.
Thank you, Arindam. It was very enlightening to know, and I think it's a very new topic. So there are many questions that we have. So normally what we do is, as I explained also, and also to our listeners today, you can type your questions in the questions tab, and Mr. Mittal, who's our moderator, would be, reading out the question, and our expert, Mr. Arindam, will answer the question. So while I request Mr. Mittal to ask his own questions first, the audience can already start typing the questions, and we can take them as they come. So over to you, Mr. Mittal. If you allow me, sir, I have one question that I would like to know from Arindam. Mr. Mittal. Okay, so Arindam, I think Mr. Mittal is on mute. While he unmutes himself, uh,
Yeah,
I hope.
I thought I am unmuted by the organizer, so I have unmuted myself.
Right, sir. So, sir,
I was listening to you.
with your permission, can I ask one question to Arindam?
Yeah, sure. Please go ahead.
So, sir, in regards to, since you have been witnessing a lot of work yourself in 3GPP, so I probably it's a question to both of you, to you and Arindam. So, how such a thing comes into standards? Is it more like an engineering thing, or is it going to be standardized
So
sooner or later?
what we are seeing that already 5G broadcast is a item of study already. There was a group called 5G Xcast who was working on it. MBMS standard that was there in CGPP is evolving to FMBMS to allow this kind of use. So one of the things is that in our presentations we have not specified, we have not what actually standard should be followed, but then we are focusing more on the course side, so that this is something that we want to highlight, is that this is something that is required, because the core part of it, especially the analytics that can be taken advantage of, has not yet been a part of the standard. But it is such a thing that not require too much standardization. It is something like Google. So Google did not evolve as a standard; it happened. So many of the things that are there in the core network, that part of it is something that is important, and it will happen anyway. That is what we feel, that it may not be too much on the standard side. So what is required in the standard side, that a kind of a broadcast standard, a kind of broadcast mechanisms are evolved, which is best suited for the kind of network deployments that we are going to see.
Yeah. Sachin, are you there?
So, Mr. Mittal, I was asking, what is your viewpoint as a standards
Yeah,
expert?
just carrying on from where Mr. Arindam left. In the last 3GPP plenary meeting, there was a study item discussed, or which will be actually put into place, is 5G NR broadcast. As Mr. Arindam said already, LTE also has a broadcast capability things. But this time in the next item, there is an indication that convergence of broadcast and broadband over mobile, how it will happen, that kind of a study is likely to be started in 3GPP. So contours of that will become clear probably by the next meeting. So that is one part, because that question I myself had, that what are the things apart from the broadcast ATSC or other standards, apart from that, what additional things will be required to be done in standards, so that both the broadcaster and the telecommunication operator can fully utilize the spectrum available and the services. So I think this is still a slightly uncharted area in the standards. Right now, the proposal which is here, Mr. Arindam will correct me, is a convergence of two standards. One is on the broadcast side. There are two or three standards which are already available, and telecom standards are already available. And the schematic diagrams which have been shown by Mr. Arindam, they show a overall view of how they will be combined. So nitty-gritties are something with a question of more details.
So, as the questions come, from our listeners, may I request you as the moderator of the webinar today, if you have some of your own questions to.
Yeah, I have one or two questions to Mr. Arindam. One is that there will be there will be a broadcaster involved, there will be a telecom service provider involved. So, what are the possibilities of subscription management here? Because the user who has a mobile device will
Unable to
only
hear.
be.
I think it got stuck.
You are not able to hear me? Hello?
Maybe, Mr. Mittal, you can repeat yourself. I am able to hear you well, but maybe for
Okay.
arrangement, you can repeat.
Mr. Arindam, are you able to hear me now?
Yes.
Okay, I will repeat. In this scenario, there are two people involved. One is telecom service provider, one is the broadcaster, and third person who is the user of service will have a mobile device. Now he will be an automatic customer of a telecom operator, and whatever services telecom operator delivers through his own network or through an offload into broadcasting, so user is transparent to that you mentioned. But
Yes.
simultaneously, as the broadcast service is also coming, and the broadcaster is becoming a kind of OTT provider himself, so how this
Yes.
subscription management happen? Is there a requirement of the subscription management entity of the telecom network to be combined with the broadcaster, and some management facility will be required for that? What is the
See,
what is
if you look
the
at
yeah?
the existing OTT players, they have managed to do it by themselves, because the only thing they require is some kind of a access to the, what do you call, the HSS or the thing which can be done indirectly. For example, if you look at, even if you look at some critical areas like even banking, so it is OTPs, one-time passwords, and all those, and what you call SMS that people are getting can be authenticated. So there are mechanisms which may not require too much standardization, but if it's standardized, it may be helpful. So one of
Yeah,
the things
okay.
that I'm quite keen to see in the coming years is that if you look at the SIM cards that are going into these mobile phones, they are quite very sophisticated cryptographic engines. And if you look at those cards that are being used at, say, for a DVB-T or a DVB-S2 kind of receivers, hardware wise they are actually almost the same, and many of them are based on a standard called the Java card. So it is possible for the cellular operators and the broadcast operators to combine at the, I mean, have a convergence at the authentication level using those SIMs, it can make it very foolproof and or many of the privacy and all the authentication issues are solved. Otherwise, what will, this is not evolved, then what will happen? It will be through what you call the one-time passwords or the OTPs or through SMS and all those things will be used to authenticate the user.
Okay. So, can I ask the second question which I have? Another is that by the time these services are actually going to become available, already there are billions of handsets in the markets. So, how are we looking at the delivery of these services to the existing customer segment, and how the UEs or the mobile devices will look like, or what will be their profiles, or whatever we can call it, when where the inbuilt capability for working with the broadcast offload systems will be available with your chip, for example, or similar chips.
Okay, so one other thing is that already if you see in Japan and Korea, we have got mobile phones and handsets which has all the broadcast receivers also, but the network is not converged. But still, this is something that is already available in some selected areas in the world. Secondly, almost if you see most of the latest Android phones, they have a USB kind of interface, so one can always easily attach a dongle, a kind of a kind of a thing to the phone, and through that dongle one can receive the broadcast information. And this is when it would be like, would like to also to inform you that we have demonstrated such a system in MWC Barcelona. So it where we had a DVB-T dongle attached to a Android phone, and we could receive both the broadcast and the broadband simultaneously, and also switch over between them in a seamless manner. So this is that are already, I mean, it is possible and also be demonstrated. But at the end of the day, what we are very keen to see is that broadcast receiver chip becomes a part of the mobile phones. So it can help in many other ways also. So because if you see the, the public disaster management and all those things are getting very important. So it is in such cases receiving broadcast frequencies on a mobile phone becomes a very important feature, because in a given area the similar services may be down, but the broadcast towers, for example, especially all the existing towers, they are built in a much more fault tolerant manner, and they can be used to send messages directly to the phone. So these kind of things, this kind of converged handsets, I believe should become a reality in very soon. Anyway, as a company, we are working on it to see it's very coming, but then it's something unrelated to, I mean, whatever we are presenting. But the thing is that we are, I mean, it is something that is going, that has, even if we don't look at convergence, having a broadcast receiver inside the mobile phones or tablets or laptops makes a lot of sense even today, even without convergence.
Right. So I had these questions only, and is there any questions from the audience? Probably not yet. So Sachin, do you have any other questions?
Yes, sir, I do have. So now our listeners are getting active. So this is just a congratulatory statement from Shesh Simha, and is mentioning that this is a great webinar and congrats TSDSI and Arindam. Please upload this to TSDSI YouTube. So I don't know, sir, if you are managing a YouTube channel, but for information of state, we definitely as project do have our YouTube channel. So all the webinars after they are over, they are recorded and they are available there. But he's mentioning that there are many folks in US and Europe who would find this very interesting, including broadcasters, TSPs, and regulators. So I would only say that what Arindam is presenting is probably of great interest. And now the questions are coming. So I have assigned one question to you, Mr. Mittal. If you're not able to see it, let me know. I can read out all.
Yeah, I will see questions. Yeah, let me see. Yeah, yeah, I have this question with me. Yeah. This question is Oh, the window is smaller. Just a minute, I will expand this. Can I expand, Sachin? Can I expand this window? Yeah, yeah, I am seeing this as no. This is the
So you can expand the question. So let me read out the question to you, so
yeah.
not to
Please,
lose.
yeah, please.
So it is from Mr. Krishna Kishore. The question is there any encryption standards follow when you broadcast in UHF?
All the broadcast standards, they have got their own cache. If you look just on UHF, any broadcast standard will have some kind of a content and cache system associated with it, with some encryption. And if you look at if you look at EMBMS, or you look at ATSCR, dash based MPEG dash based standards. So these MPEG standards inherently have their own encryption algorithms built on it. So that is something that is, that there will be, because without encryption, it is not feasible to have a kind of a mobile service, a kind of a video service, because the content providers will always be worried about what their ownership of the content, and they would like to track the whole thing. So it is there in almost all broadcast standards. So so since it's already there, so that is why I did not highlight it in this particular. I wanted to still tell that if if the broadcasters and the cellular operators agree on a common SIM kind of a thing, it makes things much more secure for them.
Okay. So Mr. Mittal, can you see the next question?
I'm seeing the question. One is about Kishore's question. Just a minute. I have been able to expand the window just now, so I will look at it. So you read out the question of Mr. Krishna Kishore. Then
Yes.
I have the next question from Mr. Vikram Tivatia. What is the implication for Indian networks?
Actually, in Indian networks, so if you look at the cellular networks, cellular network providers, service providers, because most of all of them have already deployed 4G, so you have got at least a kind of a 50 to 100 Mbps kind of a, even more than that, coming to each and every base station. So for each carrier, say for example, if my on an 8, if I deploy one 8 megahertz carrier on each of the UHF carrier on each of the towers, so it is like an incremental 25 to 35 Mbps more than that. So anyway, if you look at it, if it is fiber connected, so it is not an issue. Even if it is, so it basically, if we have already a fiber backhaul, then it is the incremental cost for transporting and implementing this SFN network is very minimal. The complexity of the broadcast radio here is almost similar, if not simpler, than a remote radio head used typically in 4G. So, and also if we look at some kind of a 20 watt or 15 watt of transmit power, the incremental power is of the order of say 100 to 150 watts. So it does not make a big strain on the existing resources that is there in a particular site. And since the sites are already there, and a subset of those sites will be used for broadcasting, so it makes the incremental cost of the network is very minimal and much less than what would have been if the particular service provider acquires a new frequency for LTE or 3G.
So should I go to the next question? The question is again from Mr. Vikram Tivatia. Which spectrum bands, broadcast bands, is this going to work on 470 to 689 megahertz?
Yes, that is the band that we are, but that is the one that is available right now in India and it is not widely used except for 1, 2 or 3 distribution channels. So this is where that is the target frequencies that we are thinking of. These frequencies, even with lower transmit power, one can reach at very large distances.
So, okay, I think this is the last question we had on the panel. So over to you, Sachin, for the next course of action.
Yeah, so there are still some questions coming, and this one is from Vinti Nair. Maybe this could be the last question
Yes,
for
sir.
Arindam. Since
I don't
India is
see
a
it on the panel.
comparatively longer yes, sir, because it just came and I didn't assign it to you. Since
Okay,
India
sorry.
is comparatively a longer way from 5G deployment, are any service providers looking at this immediately? So, Arindam,
See, this is something that unless government of India changes the utilization methods of the UHF spectrum, then it is then the things this whatever you mentioned is not practical. So first of all, the what you call the government should agree that this is something that it will allow, and the operator should also find it attractive to use this. So anyway, but then we are finding whatever we have proposed is just it can work on any 4G network or even 3G 2G networks. So there is some we are seeing some interest abroad, especially in USA, for this kind of technologies, and that is why I mean but then what we feel is that the ultimate subscription of any technologies, the mass subscription will come from India. That's why we are quite interested to see how it. I mean, we want to see it happening in India, and India leapfrogs into this technology as a, and it will anyway. It will be what we feel is that apart from just sending this what you call video content, it can be used in many other applications, including what you call IoT and many other applications where this architecture can be very useful. So we see a lot of potential in India, but then it is subject to regulatory clearance from both the Department of Telecom side and also the Dushan side and Pasarwadi side. But we are we are seeing interest from operators in this area. But then unless the regulatory sorted out, then it is difficult to do any deployment as of now.
And we have the last comment from Mr. Vikram Tewatia saying that thank you, this was useful. So thank you, Mr. Tewatia.
so I think this webinar has achieved its objective if somebody like Arindam is able to, let's say, generate interest from Cellular Operators Association of India, which Vikram is part of. So I think we are very happy, and I'm sure Mr. Mittal is also very happy
Oh, yeah, sure.
with such a platform like webinar can create meaningful conversations. So we are really thankful to you, Arindam, for taking out time, sharing your knowledge. I think the topic is very new, and probably it opens more questions than it generates the answers for. So maybe we look forward in future probably to do something more elaborate on this topic. Of course, with guidance of Mr. Mittal, how he sees, this will evolve, this topic will evolve. But definitely, it is need of the hour. I mean, this technology, the promises that it makes. So with this, without further, let's say, delaying the allocated time of this webinar, I would like to thank all the participants. I like to thank our moderator, Mr. Mittal, for coming up and creating this conversation, and you, Mr. Arindam, for taking out time and sharing your knowledge with us. Thank you,
Thank
everyone.
you.
Have a good day.
Okay, thank you, everyone. Thank you, Sachin. Thank you, Mr. Arindam.